Hi everyone and welcome into this new video in which we continue the Windows Privilege Escalation series. Now in this video specifically we will see an attack on the Windows services called unquoted service path. So as always, I hope this video is useful. If you have some feedback, positive or negative, leave it in the comments, subscribe to the channel to support me, and of course spread this video with like-minded people to help me grow. Thank you very much and enjoy the video. So we can start to talk about unquoted service path. So what kind of attack is this? Now when the Windows service binary contains white spaces but no proper quotation marks are used, then our service binary can be vulnerable to unquoted service path. So this kind of vulnerability affects those binaries that the binary path, so if we check for example the configuration with the sc.exe binary that I showed in the previous episodes, so if we check the configuration for the binary path name, which represents the executable that is going to be executed when we start the service, now for example, in this case, there are no white spaces, so there's no problem. To actually be vulnerable, you need two specific conditions. You need to have white spaces in the path, so white spaces, and also the path must miss quotes, so missing quotes. If both of those conditions are true, then you are vulnerable to unquoted service path. To actually be exploitable, then you need further requirements, but that's the idea. So how does it work? Now, essentially, consider, for example, our simple service, which is the service we are using to discuss this kind of vulnerabilities. Now, and here I have my Windows system, by the way. So here I have the prompt with elevated privileges. This is the normal prompt, so we're ready to do our exploitation, essentially. So in this system, what do we have? So let's query our simple service. So let's do here, we query for information. And notice, for now, the binary path name is the usual C users quickemu downloads simple service.exe. So there are no white space in this path, therefore this is not vulnerable. Now let's go into the downloads directory and create a couple of directories that contain white spaces. So for example, we can go into downloads here. We can do make dir example directory. Now notice this directory contains a white space and this is gonna be critical. So we do this, then we go inside this directory and then we create another directory called another directory. So very funny name here, another directory. So, and then essentially at this point what we have downloads, example directory, another directory. There are two white spaces, here between example and directory and here between another and directory. Now, let's change the binary path. So let's move the binary into this specific directory. So we're going to do a move dot to go backwards. Here I have to change the language to Italian. So here we go backwards and we do simple service and then we move it here. Perfect. So now our binary is situated in these directories which contain a white space. Now let's change the configuration of the service. So we're going to use this different shell because it has higher privileges. So let's change the configuration of this service. And now we're going to say, okay, the new service is going to be in downloads, example directory, another directory, simple service.exe. Simple as that. So we copy this and we have changed the configuration, which means that if we query now for the service here with the scqc, now notice that the binary path change. And now in this change binary path, there are white spaces. For example, here, and for example, here, and there are no quotes here. Now this configuration actually is vulnerable to this specific attack. So what's the idea of this attack? Well, the idea is that in this situation, when there is white space but no quotation marks, then the Windows operating system will not go directly to the binary that we put at the end, so to this simple service.exe. To actually get there, Windows will first try to execute different binaries using a predefined series of rules, and then at the end you have the final binary. So it's kind of like a weird searching for the right service path, because Windows does not understand exactly where it is found. So for example, if we stop here the service, so now the service should be stopped anyways, let's just stop it again. So I'm gonna copy this, put it here. It says, look, the service has not been started, there's no problem, we can start it, and now it's starting, perfect. And now we can stop it again because nothing happened. That's good. Okay, now when we start the service, what actually happens is that Windows will search first for the example.exe binary in the downloads folder. If it doesn't find anything, then it moves to the another.exe binary in the example directory folder. And then if it doesn't find anything, then finally it arrives at the simple service.exe. So let's say that an attacker is able to write an arbitrary file in the downloads folder. Then an attacker can introduce a malicious file called example.exe. And notice that in this case, the name matters a lot because it has to be exactly example.exe. And if the attacker is able to do that, when Windows will start the simple service, it's actually going to search for this bin path, but then since the bin path contains white spaces, it's going to break it first here in example.exe. It's going to try to find this binary. The binary exists, and therefore Windows will execute that binary. So this vulnerability has to do with the ambiguity that Windows searches different binaries instead of the final one. Now, to be honest, I don't know exactly internally why Windows does that, but essentially this is what happens. It probably does that because it cannot, with its algorithm, determine the final path, because probably these white spaces are interpreted in like the wrong way, sort of, so it goes into the example.exe. If it doesn't find this, it jumps into the next directory and it goes into the another.exe, and so on and so forth. As I said previously, this opens up the possibility for an attacker to introduce a malicious binary in one of the paths that Windows searches for. If the attacker is able to write in one of those directories, maybe not the first but the second, it doesn't matter. It just matters that one of those directories is writable by the attacker user. If this is true, if the attacker can write in any one of those paths, the attacker is able to hijack the execution flow and to execute a malicious binary. For example, let's say that we have a malicious binary. Now, I don't have it here yet, so let's generate it. I can generate it with MSF Venom. So pretty simple. So here I'm generating it, it's malicious.exe. So now that we generated the malicious.exe binary, we can just transfer it with netcat. So as always, we do netcat malicious, not nodes, but malicious. Here we do netcat. Okay, I have to change once again the language to Italian. Netcat 192.168.1.2.2.1, and then malicious.exe. Okay, now notice that we receive a connection, and now we have our payload. Now this malicious payload allows us to obtain a shell with the port 777. So specifically, let's say I put listener and then I execute the payload. Notice here I get a shell. So nothing new, I'm quick emu, and this is the idea. So how can we abuse the unquoted service path? Well, what's the idea? How does the attack work? First, we obtain the configuration, so with this simple command, and then we say, okay, look, this command is not quoted and it has spaces. This could be vulnerable. So we have to check if we can write in different directories. The first directory is literally the first things, the first time we get the space, we stop in that place, we go to the previous directory and we create the file name example.exe. So in this case, it is the downloads directory, which means that if we can write into the downloads, then we can exploit this attack. In this case, of course, we can. And it's actually pretty simple because you just have to create a copy of the malicious and we're going to call it example.exe. So notice now we have this example.exe. When Windows will try to start the simple service, the first executable that is actually going to get executed is going to be the example.exe in the downloads folder, which now is just become the malicious one. So let's put a listener once again. Let's start our service with the start simple service. So we can start with this order. And notice I get a shell. I get a shell because the first executable that Windows found was this example.exe. So this is like a pretty important vulnerability on the configuration of the service, of course. So I exit. Here it said, of course, that the service could not be started, clearly, because it was a malicious reverse shell. And of course, there is some security things which we do not care. Anyways, now let's say though that we could not write into this specific directory. Could we not exploit this? Well, actually, since in this case there are multiple directories with white spaces, we can try with this other white space. So the other executable is going to be another.exe in the directory of example directory. So the idea is pretty simple. So let's go let's copy, let's move actually this example.exe. So we do a move example.exe. We're gonna move into the example directory and I'm gonna call it another.exe. So now if I go into the example directory, I have this binary called another.exe, no longer example.exe. Now in the downloads there is no example.exe. So the same idea applies. I start the service and notice I get once again code execution, because now what got actually executed is this another.exe. And to prove this point, let's rename it with another name. So with another2.exe, so a different name, right? So I remove from the shell, I put a listener again, I try to start the service again, and notice now no shell is started, because now this executable was not actually executed because it's called in a different way with respect to the directory path. And so what actually got executed is a simple service exe, which is the valid service. So we can stop this. This is just to showcase that in this attack, we need to write an arbitrary, not really an arbitrary file, but like a specific binary with a specific name in a specific directory. So that's the main idea of the attack. Now to make it more clear, I brought some more example. So for example, let's say there is this service path. So we have program files x86 company app.exe. So like, you know, an arbitrary service that a program might install in the system. So for example, in this case, how many binaries will the Windows operating system search before actually getting to the final exe? So first it's going to try to execute the program.exe, which means that if the attacker can write the program.exe in the C root, so in the file system root essentially, then we have code execution. The next thing it's going to do is going to actually execute program files.exe, also in the C root. If it doesn't find both of these, then it goes to the next directory. Now in this case, notice that it skips completely the company, because the company portion of the path is just made of one word with no white space. So it's gonna go to the company app. To the company app, it's gonna break on the white space. So it's gonna find the program company.exe that has all the previous paths still valid, which means that if the user can write in the company directory in this one, in this path, so C, program file 686 and company, then once again, we have code execution. And after that, it arrives at the final binary. So this is one example. This is another example. So we have program, cool company, cool binary.exe. So here the white space is actually in the binary name. That is to be found on the name of the executable. Now, if this is the binary path of our service, then Windows first will search for cool.exe in program in C. Then it's going to go into cool.exe of this order, of the name of the binary. So cool is repeated, but remember, first cool.exe is for the first white space, second is for the second white space. So essentially, the algorithm you must have in mind, sort of, you can think of is, okay, I go towards the first space, perfect. I remove everything that is after and I put an exe and I try this binary. There is nothing there, okay, I move to the next space. Okay, to the next space, I put an exe and that's it. Then to the next space, okay, the next space, here I put an exe and that's it. So that's the algorithm. By having this algorithm, you will be able to figure out all the different executables that Windows will try to search for, and then you have to ask yourself, okay, as an attacker, as the current user, can I write a file in the C drive? Can I write a file in the company folder? I mean, maybe it's really difficult to write in the C root, but maybe it's easier to write in the company folder. And then if you are able to write in the company folder, you just have to make sure you write the file with the right name. Otherwise, as I showed before, the attack doesn't work anymore. So that's essentially the idea. And by connecting this specific attack on services with the attacks that we saw in the previous videos, in the previous video, we talked about weak services, so weak config. So weak config at the level of the binary permission or at the level of the service permission. In this case, we are saying it's sort of like another type of weak configuration in the binary path, but it does not have to do with the fact that we're able to change that binary path. We do not have to touch the binary path. It's just that if the binary path contains white spaces and there are no quotes around that binary path, then Windows will actually search for more than one executable. And then we can introduce maybe malicious executables. So the idea is that to be vulnerable, we need white spaces and no quotes. To actually weaponize this vulnerability, to actually make it an exploit, we need to find a path where we can write on. And this attack is all about getting from the binary path of the service, you enumerate all the different paths, and then you understand, okay, can I write in the company folder? Can I write in the cool company folder? And so on and so forth. This is the basic idea. Now, when it comes to automatic enumeration, you can also use the winPEAS tool that I showed in the previous video, because it's going to enumerate a bunch of common vulnerabilities, including the essentially no quotes and space detected, so including the unquoted service path vulnerability. Specifically, let's execute it on the machine. So here I believe that I had it downloaded. So let's go into downloads. Here it's winPEAS.exe. So I do winPEAS.exe quite services info, exactly the same output as I showed in the last video. I execute it. And notice now that what do I get is, okay, you can start and stop some services, but the idea is that, well, I have file permission, I have DDL hijacking, which I will talk in a future video. File permission, I already discussed in a previous video. DDL hijacking, I will talk in a future video. And then we have no quotes and space detected. So essentially, it gives us the binary path of the service, and it says, look, there are white spaces here and here, and there is no quotes. It means that the operating system will do this funny search for all the different binaries before reaching the desired one, which can be problematic if our user can write in one of those binaries. So that's interesting. Now, to finish off the video, a quick note on fixing this vulnerability, because it's actually extremely simple. So when you configure a service in Windows, make sure that you have quotes around the path if the path contains white spaces. So how can you do that? Well, you can go into the regedit, so the regedit, the registry editor, essentially, of the system, and then you can search for, so let's put it on the side so that it's more clear. So we can search for the keys of the, essentially this thing, so I will already open, but let's go into HKey local machine, then we go into system, then we go into current control set, so like current control set, this one, so like we do HKey local machine, system, current control set, services, then we find our service, which in this case is simple service, so simple service, and then here we have a bunch of lines in the registry, and what we want to change is the image path. So this one we do modify, and essentially we add a quotes at the beginning and we add a quotes at the end. So now we do this, and look now that there are quotes on this, so we can just close this. And what we can do is, okay, let's try now to exploit again. So let's try to exploit again as we did. So we have a shell running, perfect. So now let's first let's get the let's check the configuration again. So with the essentially, let's go back to the commands to this SCQC to check the configuration. Notice now that I see the quotes, so this is no longer vulnerable. So what do we have here? Let's go into example and let's move this another 2 into another.exe. Now previously this worked, previously with this we were able to obtain a shell. So let's try it now. So I'm going to do a start, I'm going to start it, and notice no shell. We obtain no shell because we fixed the vulnerability, because we quoted the path of the service. And this is enough to do this. Now, if you want to change this directly from the command line, you can actually do it in a simpler way with the scconfig command. So to change the configuration of a service, here, notice this, what do? We add the quotes, and here we have to escape the quotes. So essentially you just, let's first remove them. So I'm gonna show it. First we remove the quotes, so there are no quotes anymore. So like this we would just remove. So this is another directory, and then simple service. So with this, I just remove the quotes. I have to copy it better. So I do this, I put it here. So now if I check the service, there are no quotes, which means that now if I stop and start the service again, stop and start, I get a shell, right? So now how do we fix this? Here I can exit, whatever, perfect. So how do I fix it? Well, when I change the config essentially, so when I change the config, I just have to change it by putting the quotes and by escaping the quotes, like this. So another directory, so let's remove everything here, and let's change the config, but this time with the quotes. So look at this now. Here I have the quotes. Notice the difference here. No quotes vulnerable, quotes not vulnerable. I listen again down beneath. I start the service again, and I get no shell. I get no shell because the vulnerability has been fixed. If I try to enumerate with winPEAS, notice, while it's not here of course, it's in this previous directory. Now I get the previous vulnerabilities of course, but I do not get anymore the unquoted service path. I get file permission and possible DDL hijacking, but I do not longer get, look, there are white spaces and no quotes, because we fixed that. And here below I put some references that describe the same attack I described in this video. As always, I hope the video was enjoyable. I hope you got something out of it. If you did, leave some feedback, share this video with like-minded people, and to the next video where we will keep seeing different ways of exploiting Windows services.